Okay guys, today we're going to learn how to calculate an empirical and a molecular formula. And so this kind of combines the formulas that we had been putting together, but then also it combines some mole conversions in it as well, some molar mass information. So the empirical formula shows the lowest whole number ratio, of elements in an atom or in a molecule. So our molecular formula would be C4H8, 4 carbon, 8 hydrogen. It tells us exactly what's in there. The empirical formula just tells us a ratio. So you want the lowest possible number. So each of those are divisible by 4. So the ratio is for every 1 carbon, there's 2 hydrogen. We can do that with other things as well. So if we look at all of these, they're all divisible by 2. So when we divide by 2, it tells us for every 1 carbon, there's 4 hydrogen and 1 oxygen. So it's just a ratio comparison of the types of elements in a compound. The cool thing is, though, is that experimentally, we can determine this empirical formula in lab. So let's say that in lab, we do a reaction and we end up with a compound that is 5.75 grams of sodium, 3.5 grams of nitrogen, and 12 grams of oxygen. And I want to know, what is the empirical formula? So there are kind of 3 major steps to do this. So the first step is going to be calculate the number of moles of each element. And we know that if we have the mass, we can use the molar mass to calculate the number of moles. So a shortcut for this is that we're going to take the mass divided by the molar mass for each of these elements. So we are going to take the mass of sodium, 5.75 grams, and we're going to divide it by its molar mass, 22.99. So 5.75 divided by 22.99, we end up with 0.250 moles of Na. I'm going to do the same thing with my oxygen and my nitrogen. So I've got 3.5 grams of nitrogen. Its molar mass is 14.01. So I end up with 0.2498 moles of N. And then my oxygen is 12 grams, and it's 16. 12 divided by 16 is 0.75. So now I've determined how many moles of each substance I have. I'm not too worried about rounding at this point because it's not my final answer. So now I need to find the smallest number ratio. And so I need to compare these values with whole numbers. So to turn these into whole numbers, I'm going to divide all the moles that I just found by the smallest number. So the smallest number I got was the 0.2498. So I'm going to take 0.250 divided by 0.2498. And I get 1.0008. Nitrogen was the 0.2498. So that divided by itself is going to be 1. And then my oxygen, 0.75 divided by 0.2498 gives me 3.002. So what I'm going to do with those values is hopefully they are whole numbers. So at this point, I'm going to write the empirical formula. So for sodium, it shows us, what this shows us is that we have 1 sodium, so it's going to be Na. We have 1 nitrogen, N, and then 3 oxygen, so that's going to be O3. So we found the formula for sodium nitrate. Okay. Let's try it again. We want to know the empirical formula of a compound with 75 grams or 75% carbon and 25% hydrogen. When we're given these percentages, the easiest thing to do is assume a 100-gram sample. So 75% of 100 grams is 75 grams. And 25% of a 100-gram sample is 25 grams. And now we're at the same starting point as we were above. So step 1 is to calculate the number of moles of each element. So 75 grams, we're going to do carbon first, divided by 12.01. Gives us 6.244796. And hydrogen is 25 grams divided by 1.0016. Sorry, 008. That is 24.801587. Again, I'm just keeping all the values because we're not at our end answer yet. Okay. Step 2 then is to divide by the smallest number to make this a whole number. So my smallest is my 6.244796. So that gives me 1 carbon. 24796. So 6.2. That gives me 3.97. And when we round that up to a whole number, it's really close to 4. So I'm going to say that this is 1 carbon and 4 hydrogen. So our empirical formula for this one is CH4. Okay, you guys. So now we can take this one step further and we can find the molecular formula. So the molecular formula shows the actual number of each element in a compound. So where the empirical formula shows the whole number ratio, the molecular formula shows the actual number of each. So when you're done with it, those values may actually be divisible into a smaller value. Okay, so the way that you find a molecular formula is you find the empirical formula first, and then there's kind of 2 more steps. So we want to know what is the molecular formula of a compound that contains 42.56 grams palladium and 0.8 grams hydrogen and has a molar mass of 216.8 grams per mole. I want you guys to pause the video and find the empirical formula using the values of palladium and hydrogen. Okay, so we divided each by the molar mass and we found PDH2 for our empirical formula. So for every 1 PD, there's 2 hydrogen. So this is where the new part comes. We're going to determine the molar mass of the empirical formula. So 1 PD is 106.42, and then 2 hydrogen is 2.016. So that is a total of 108.436 grams per mole. Okay. Now what we're going to do is we want to find the ratio between the empirical formula's molar mass and the molecular formula's molar mass that we were given up in the problem. So we're going to take the molar mass of the compound. This will be the value we're given in the problem. And we are going to divide it by the molar mass of the empirical formula that we just found. Grams and moles cancel, so it ends up being a ratio or a comparison value. So when we take the 216.8 and we divide it by 108.436, we get the value of 1.999. Now here's some rounding rules. If it's close, you're just going to round to the value. So in this case, 1.999 is basically 2. So what that tells us is that the molecular formula is twice as big as the empirical formula. If that were to end in like a 0.5, to make that a whole number, you just double it. If it ends in the 0.33, 0.66, that's a third or 2/3. So you're going to multiply by 3 to get it to be a whole number. And if it's 0.25 or 0.75, you multiply by 4 to make it a whole number. So if it's very close, you can just round it. But if it's one of those halves, thirds, or quarters, you need to do this extra step to make it a whole number. Okay, so once we have kind of our divider number, then we're going to multiply the subscripts of the empirical formula. So we got PDH2. And what that number tells us is that the molecular formula is twice as big as that. So we're going to turn PD1 into PD2 and H2 into H4. So this is our molecular formula. So it's actually, if we had a compound of this, 2 palladium and 4 hydrogen. Okay, you guys, I want you to try 2 of these. So pause the video, and I'm going to work it out as well, and so you can check your answer once you have tried it. Okay, so number 4 has a little twist. When you get to the empirical formula, you've got the 2.25. That's way too big to round. It's not close enough to 2. So we see that 0.25 ending, so we are going to multiply it by 4. And what we do to 1, we have to do to the other. So that 1 also needs to be multiplied by 4. So the empirical formula that we come up with is the C4H9. Then we find the molar mass of that, and we take the molar mass given to us in the problem divided by the molar mass of our empirical formula to find 2. So our multiplier is 2. So our molecular formula then becomes C8H18. Okay, go ahead and try number 5 and then check back. Okay, so for number 5, hydrogen peroxide, we found that the smallest value we're kind of both the same. So we came to 1 and 1.0047, close enough to round to 1. So our empirical formula is HO or OH. And then when we find our molecular formula, the value we're given in the problem divided by the empirical formula is 2, and our molecular formula is H2O2. Keep in mind, you guys, when you get to this step here, the molecular formula divided by the empirical formula, if they are the same, it's not necessarily a mistake. The molecular formula and the empirical formula could be the same formula. So if you get a 1, that just tells us that the molecular formula and the empirical formula are the same. So you guys are going to do a few book problems now. The back of this page is completely empty, so I want you to do the work there. You are going to do problems 3.46. See, I'll write it here. 3.46, 3.50, and 3.52, just A. You don't have to do all of them. So this will be what you'll work on for the rest of the hour, and it will be due Wednesday at the beginning of class.